Welcome back. This is part 2 of this lesson. We're going to continue immediately from the end of part 1, so let's get started. Now, another process which uses asymmetric keys is signing. Let's review an example. The robot general wants to respond to the battle plans. So let's say that the robot general has received the battle plans from the cat ruler and he wants to confirm A, that he's received them, and also that he agrees to them. Remember that battle plans require both sides to operate as one, and so the cat ruler needs to know that the robot general has received the plans and that he agrees with them. The general might want to respond with a simple OK message, so we'll send a message saying OK to the cat ruler. The issue is that anyone can encrypt messages to another party using asymmetric encryption. You or I could get hold of the cat ruler's public key and encrypt a message saying OK and send it to the cat ruler, and the cat ruler wouldn't necessarily be aware whether that was from the robot general or not. Just because the cat ruler gets a message from what appears to be the robot general saying OK, it doesn't mean that it's actually from the robot general. It could be from a human pretending to be the robot general. Encryption does not prove identity. But what we can use is a process called signing. With signing, the robot general could write this OK message, and then he could take that message and using his private key, he can sign that message. Then that message can be sent across to the cat ruler, and when the cat ruler receives that message, he can use the robot general's public key to prove whether that message was signed using the robot general's private key. So this is the inverse. On the previous example, I demonstrated how you can use the public key to encrypt data that can only be decrypted with the private key. In this example, we can take the robot general's private key and sign a document, and then the public key of the robot general can verify that that document was signed using its matching private key. And at no point is the private key revealed. It's just because of this relationship between the public and private key, the public key can verify whether its corresponding private key was used to sign something. And so signing is generally used to verify identity. As long as we can be sure that the public key belongs to the robot general, and generally this is done by the robot general uploading his public key to his Twitter account or putting it on his cloud storage or his website, as long as that verification exists, we can get the public key and verify that a document has indeed been signed by his private key because of that relationship between these two keys. So key signing is generally used for ID verification and certain logon systems. Now there's one more thing that I want to talk about before I finish up this lesson, and that's steganography. Sometimes encryption isn't enough. The problem with encryption is that if you use it, it's obvious that you've used it. If you encrypt a file and deliver it to me, there isn't really any scope for denying that you have encrypted some form of data. The government, who control the men and women with guns, can often insist that you decrypt the data, and if you don't, well, they have pointy sticks or they can put you in jail. You can refuse to decrypt the data, but the deniability isn't there. If you encrypt data, somebody will know that you've encrypted data. Now, steganography is a process which addresses this. If you've ever used invisible ink, the kind which only shows under a certain type of light or when heated, that's a physical form of steganography. It's the method of hiding something in something else. With steganography, the cat ruler could generate some ciphertext and hide it in a puppy image. The image could be delivered to the robot general, who knows to expect the image with some data inside and then extract the data. To anyone else, it would just look like a puppy image, and everybody knows there's no way that the cat ruler would send the robot general a puppy image, so there's plausible deniability. The effect of steganography might be a slightly larger file, but it would look almost identical. Effective steganography algorithms make it almost impossible to find the hidden data unless you know a certain key, a number, or a pattern. Steganography is just another layer of protection. The way it works at a foundational level is pretty simple. Let's say that we wanted to hide a simple message. Just hi. Well, the decimal values for H and I are 8 and 9. So we might take the puppy image and pick 2 random pixels and change the colour by 8 and 9 respectively. The steganography algorithm would take the original picture, select the required number of pixels, adjust those pixels by a certain range of values, and what it would generate as an output would be an almost identical puppy image. But hidden there would be slight changes. And if you don't believe me, let's blow this up a little bit, because this is an actual simple example of steganography. If you look really closely at where those arrows are pointing, the colour is slightly different than the background. The first pixel has been adjusted by 8 values, and the second has been adjusted by 9 values. And so if you knew the location of these 2 pixels, you could take the second image and extract the text. Now, this is a super simple example. A real algorithm would be much more complex, but this is at a base level how the process works. It allows you to embed data in another piece of data. To be really secure, the cat ruler would encrypt some data using the robot general's public key, take that ciphertext, use steganography to embed it in an image that wouldn't be tied back to the cat ruler, send this image to the robot general, and then the robot general could also use steganography to extract the piece of ciphertext and then decrypt it using his private key. And the same process could be followed in reverse to signal an OK, but the robot general, in addition to encrypting that OK, would also sign it, so the cat ruler would know that it came from the robot general. With that being said, go ahead, complete this video, and when you're ready, you can join me in the next.